So now we're going to use those definitions for the derivative of the trig functions. Could I please encourage you to look carefully at the trig function? Not just to notice whether it's sine, cos and tan, but to also see whether there's a little function. If it's in a little function in x, maybe it'll be a trig function and a function in x, or it could be the product of functions or the quotient of functions. And in all of those situations, you have to use the overarching rules for differentiating functions of functions, product of functions, or quotient of functions. Okay, so let's have a look. In A, we're differentiating, couldn't get much easier than that. So our notation would be dy dx, and sine goes to cos, and there's no complication there. It's cos of x. B, y is the cos of x, so dy dx is minus the sine of x, no complication. H, where y is equal to the tan of 4x. A little slight complication, I guess, in that it's the trig ratio of a little function in x. So you have to use the function of a function rule. We know that tan differentiates to give sec squared of this function of 4x, but we'd have to multiply by the derivative also of this little function using our original very first rule for differentiating, which will give us 4. Probably that 4 will be taken to the front and your derivative would be written like that. And in I, y is 4 times the tan of x. Really, this is not much different to y is equal to 4x. When we differentiated that, we took the 4, differentiated, kept the 4, differentiated x, which is 1, and so we get, dy dx is 4. Here, we will, to find dy dx, we'll keep the 4, and we will differentiate tan of x. Differentiating tan of x is sec squared x. And that's our answer. Now, you should be able to get started with some of these easier ones in exercise 4e, questions 2, 3 and 4. I'll do some more complicated ones involving the product and quotient rule with you in class, but I think hopefully you won't have any trouble getting started. And work through as many of those as you can before class.